Question 2, this is about decomposition of a metal carbonate. So a metal carbonate can decompose when you heat it. This reaction is called thermal decomposition. So occasionally they ask you on what is the type of reaction, whether you're doing theory or practical, whatever. You should know it's a thermal decomposition reaction. Give off a gas that turns lime water milky. So that is CO2 gas. Carbon dioxide gas turns lime water milky or cloudy. And that is a result of CO2 reacting with lime water, which is actually saturated solution. So it is a aqueous solution. It is soluble, okay, but it's the maximum amount of this that can dissolve in that volume of solvent. So calcium hydroxide is lime water, is saturated lime water solution. So this is acidic oxide, as you know. Carbon dioxide is acidic oxide, and this is a base or an alkali, whatever you pronounce it, doesn't matter. I mean, as long as you know what it is, it shouldn't matter, right? As long as the chemistry is correct. So what you will get is you will get a salt, and the salt that you get from CO2 is what you call CO3 2 minus. It's a carbonate salt, and the metal carbonate that you're going to get is from the Ca2 plus. So what you have is you will have Ca2 plus, and if you know something about lowest common multiple says, well, for ionic compound, you must reach the lowest common multiple of the cationic and the anionic charge such that you get an ionic compound salt, which is uncharged. The overall compound is uncharged. 2 plus cancel out 2 minus, that's why it's CaCO3. And there is also H2O being produced, acid plus base neutralization reaction. So the H2 give you the H2, there is O2, but one of the oxygen is gained from the CO2, gain the oxygen to give you carbonate ion, and the other oxygen is left to form water. This thing, if you have learned not A2, I was going to say all level metal carbonate. Okay, so the group 2 carbonates are not very soluble, so that is insoluble, and that turns lime water milky because there's insoluble in water. It looks like a milky precipitate, a chalky precipitate, because what you have in a chalk or limestone essentially is just calcium carbonate. All right. Anyway, so the students separately heats each of the metal carbonate. You need a Bunsen burner to heat it. You measure the time taken for the lime water to turn milky. So the longer the time, it's not really a trend, but I guess longer time for lime water to turn milky, that means it takes longer, it takes more energy. It takes more energy to thermally decompose. That's why it's much harder to decompose to give you the CO2. Therefore, more difficult to decompose. So you need to appreciate that the more difficult it is to decompose, you need to heat it for longer, and therefore it will take longer time for the CO2 to be produced. Therefore, it will take longer for the lime water to turn milky. Here, just now I keep on writing CO2, and they will be wrong here because you should read the question. Name. They don't say give the formula. They don't say state the gas. They say name the gas. All right. And moreover, they just told you that it's a gas. So tests for gases, there are very few that you would have learned in your O level. That therefore it's carbon dioxide and not CO2 there because they wanted the name. Next bit, the amount of heat supplied must be controlled. Okay, if some of them you heat it a bit strongly, some of them you heat it a bit less strong, then it's not really a fair test. This is to ensure a fair test. Okay, in any science experiment, we are talking about a fair test to ensure that other people doing the same experiment would consistently get the same result. Okay, so how can you ensure that the Bunsen burner heat is kept constant? Okay, so I guess if you heat it from here, then you must maintain heating it from here. So maintain the same distance between the tube and the fire itself. All right, so maintain same height where tube is held, basically therefore same distance from the flame, meaning the Bunsen burner, to the tube is the same distance. And then the other issue, of course, is how do I ensure that the flame that I use, like when you open the A hole and you get a blue flame, how can I ensure the blue flame that you use is the same intensity between this boiling tube and the next boiling tube and the next? All right, so if I were you, I will have the 4 boiling tube already. All right, and I will not turn off the Bunsen burner, but I will just keep using the Bunsen burner with the same intensity and the same air hole, without adjusting the size of the air hole, without adjusting the how do I say this, without adjusting the gas valve at all. So you don't want to increase or decrease the volume of gas flow, because you want to ensure that the blue flame itself, the intensity itself is the same. So you want to maintain, do not change gas, do not turn gas valve, do not adjust the air hole, to let in the thing. And better still, if we keep the same Bunsen burner burning at the same intensity. So if you just continue one experiment to the next without turning the Bunsen burner off, but of course that's not entirely practical, because it might run out of gas at some point if you continue doing that. All right, but doing this, at least it will minimize whatever you need to do. Okay, but I guess if we don't turn off the gas valve, then essentially we don't turn off the Bunsen burner. So that's pretty much saying the same thing. All right. Control variable is one of those things. It can affect the result of your experiments. So in this case, your experiment is decomposing the carbonate, giving off carbon dioxide, and you record or you measure the time taken for the lime water to turn milky. All right, so 2 other variables that can affect the experiment, but you don't want it to. All right, 2 other things that can affect the experiment, but you don't want it to. This lime water turns milky because of this reaction. If I have more lime water, then I need more CO2 for it to turn milky. And therefore, across all my experiment, I must use the same volume of lime water. The same volume meaning they will fill to the same height, meaning to say I will have the exact same lime water from the same bottle. They are the same lime water, they are the same volume that I use. All right. You can also think about the metal carbonate. I should use all of them of similar sizes or similar surface area. I do not want to be comparing heating something which is powdered versus heating something which is granular or lumpy, not powder essentially. Okay. What else can I say? If we are comparing these reactions, they actually give you the carbon dioxide. So I need to know the quantity, okay, in terms of mole, because these will be equations. Assuming that these metal carbonate that decompose will be divalent meaning to say, what am I talking about? Divalent meaning to say M2 plus CO3 2 minus. So the solid decomposes under heat to give you MO and CO2, and that CO2 is the one that reacts to give you the milky precipitate. I'm assuming it's divalent, so if it's all divalent, they just give you 1 CO2, and therefore we need to ensure that we use the same mole of this as part of the control experiment. But one of the easiest thing really is to think about the surface area as well as the volume, the quantity, the mole of the lime water used. All right, it's very important. And if we use the lime water from the same bottle, that means the concentration is the same, but we need to ensure the volume is the same as well for it to be control variable. So keep 2 variables must be controlled. Keep volume, keep the volume of lime water use constant. Use from the same source. So you don't want to use a different bottle of lime water for your different experiments, and then use same type of solid of specific surface area. Meaning to say, if you use powdered, either powdered or you use the lumpy, but preferably it will be powdered because you want to speed up the rate of reaction. Okay, so which metal carbonate is the slowest to decompose? So to give you a table, right? So as I was right, I shouldn't have worried about the divalent thing because these are all calcium 2 plus, lead 2 plus, magnesium 2 plus, zinc 2 plus. These are all divalent cation. Slowest reaction, slowest to decompose mean it takes the longest time. 500 is the longest out of all of these. So calcium carbonate is the slowest to decompose. Calcium carbonate. Suggests how the investigation can be improved to make the results more reliable. Reliability is to do with, can you reproduce it? If someone else do this experiment another day, can the person get the exact same result? So if you do this a second time, can you get the same result? And therefore, to ensure that you can get the same result, you will repeat the experiment. Here you only did it the first time. The second time taken for lime water to turn milky, in the second experiment, you will have a result, and then you compare. Are they very similar or are they way apart? If they are way apart, you might need to do a third time and compare. All right, and you take average in order to get the best concordant result, in order to average out any small bit of errors. Okay, so suggest how it can be improved for 2 marks and 3 lines. So in A-level experimental planning and analysis, we always say we need to repeat the experiment. To get consistent results that are close or within each other. In titration, this is called concordant titer. In any other experiment, it's called concordant values. All right. Then we average these values that are close to each other. So we average these concordant values, or these values that are really close to each other, that we deem are accurate enough when we repeat the experiments. Okay. Right, so one is what would you do, the other one is what else would you do to process the data to make it more reliable.